Okay, this is gonna be about the next, the next step in understanding Smali, reading it and being able to take Smali code and turn it into pseudocode. So what I'm gonna do here is I'm gonna open a text editor. Okay. Now the goal is to be able to write some Java code, some pseudo Java code based off reading this Smali code. So you see here, I'm going to focus on this method right here. All right. So, all right, what do we have? We have a method, public final perform math operation. So let's, actually I'm going to do this in Kotlin because I like Kotlin better. So I'm going to write fun and then perform math operations. Okay, now you see here it has 3 integers for the parameter. You can see these parameters, P1, it's in P1 register, P2 register, P3 register, and you have A, B, C, and they're integers. You see the I, 3 I's, and it returns a D, which is decimal. So let's write this out. We have A, which is an int, B, which is an int, and then C, an int. And it returns a double. Okay, we got that so far. We've done all of this so far. Now let's get to right here, line 8. We have const 4 bytes. So we're allocating 4 bytes to put into register V0, and it's this hexadecimal. All right, so let's just do a little sanity check here. And let's do, okay, what is 0x0? What is that? 0. Okay, that should have been pretty straightforward, but you can see here it's in hexadecimal, it's 0. Close that terminal. Okay, so let's write this out. We have v0 and it's set equal to the integer 0. Okay, so now we've done this, we've done all of this. Let's keep going. Okay, local v0, and it's setting it to sum, so it's referencing it to sum. So let's do sum equals, or we do v0 equals sum, that's the name, which is equal to 0. Okay, and then add int. So we're doing addition here. We're adding these two, P1 and P2, and we're storing it in V1. So let me bring this down a little bit, get it closer. Okay, so we're adding, oops. Okay, we're doing this. Okay, we're gonna put into V1, we're setting it equal to P1 plus P2, which is equal to what's in P. We see P1 here is A and P2 is B, so that's going to be equal to A plus B. All right. So let's keep going. We're going to do multiplication of integers, and this is the to address. So it's going to be V1 times P3, and then you set that value into V1. So we got V1 equals V1 times P3. Okay, and we know, you know what, let's go back up here and just set this P1 equals A, P2 equals B, P3 equals C. And that's these right here. And you can see that right here. Okay, so let's keep going. Now we get to line 10 and local v0. So it's ending this register. So this register is being ended. So let's do v0 equals null. All right. Now local v1 is equal to sum. Now v1, okay, so you see here v0 was sum, now v1 is equal to sum. Let me add some space here. Okay, now we're going to do division. So we're going to divide v1 by p2 and store that value, that result, into v0. So we'll go v0 equals v1 divided by p2. All right, do we have values for p2? Okay, yeah, so v1 is set right there and p2 is passed in as b. Okay. All right, that gets put into v0 after it was set to null. So we're good up to here. Now let's keep going. Local v0 is equal to temp, so it's reusing that v0 register again, and it equals temp, variable name. Now let's keep going. xor-int to addresses. So it's gonna do v1 xor v0, and it's gonna store that result in v1. So v1 equals v1 xor v0. Okay, let's keep going. Int-to-double. So it's going to cast, it's going to turn an int into a double. So it's going to do, let's look this up real quick. All right, we're looking up int-to-double. Int-to-double. Okay, here we go. Converts the integer in vy into the double in vx. Into the double in vx. Vx plus 1. See, here's an example. Int-to-double v6 v0 converts the integer in v0 into a double in vx v7. Converts the integer in converts the integer in v0, so it's going to convert this integer, which is in v1, into a double in v6, into v2. So is there a v3 made? Locals 4. Let's see, there's 4 local registers. We have v0, v1, v2. Oh, okay, so it must put it in v3, but it's not being referenced any further, right? 0, 1, 2, 3, and there's 4 local registers. So, okay. When you see locals 4, that's how many local registers are being made. And you see, so it's going to be the V's, v0, v1, v2. Where's that? v2. That's 3, but it says there's 4, so that must be the 4th one. Okay, so let's go back. Let's read it one more time. Int-to-double. Where'd it go? Int-to-double. Converts the integer in vy into the double in vx. Okay, so let me go back to the text editor. Okay, so it's going to do, we're doing int-to-double here. So v2 equals v1 as double. This is in Kotlin. And then return, what is return wide? Let's look up return wide. Return wide, return with double, returns with a double long value in v0, v1. Returns with a double or a long value in v0, v1. Okay, so I think v0 is the double and v1 is the long. I think that's what it's saying. So it's going to return the double. Return v2, which is a double. You can see here it's cast to a double. So let's try now to, here's our pseudocode, our Kotlin pseudocode. Let's see what we should get if we pass some numbers in here. Let's say a equals 2, b equals 4, and then c equals 7. Okay. So we have 2, 4, 7. Okay. Let's see, where do we first do some math? Okay, v1. So let me put some space or delimiter here. So p1, which is a, which is 2, plus b, which is 4, and that equals 6. So we're going to get v1, yeah, equals 6. All right, let's keep going. All right, now we have v1, which is 6, times p3, which is c, which is 7. And that equals 6 times 7 is 42. And that gets set into v1. Okay, we recycle v0. v1 becomes sum, so sum equals 42. Okay, now we got v0. Okay, let's see. v0 equals v1. What's in v1? v1 equals sum, 42. So 42 divided by p2. What's in p2? Let's trace it back up. p2 is b. That's 4. So 4. Let's do 42 divided by 4 equals 10.5. And that equals v0. Okay, now we've given v0 a reference to temp. So temp equals v0, which is 10.5. Now let's keep going. Okay. Okay, v1 equals v1 xor v0. So we have v0. Let's write this out. v1 equals v1. What is currently v1? v1 is this, 42. 42 xor v0. What's in v0? 10.5. Okay, so to A, and what's the other one? 10.5. So it can't be floated as an integer, so I think it's just going to do 10. I think it's, yeah. Yeah, so I think it's just going to do 10. Okay, so 32. I could be wrong here. So this is going to be, after this xor, it's going to be equal to 10. Is that right? Or no? Oh, 32. This is decimal. 32. Okay. Okay, v2 equals v1 as a double, so it's just, now it's going to be 32.0 equals v2. And then returns 32.0. Okay, let's see if I got this right. We're going to pass into this function 2, 4, and 7. So I'm going to go to my code here, perform math operations. All right. I'm going to run this on my phone, and then I should see in the logs a result of 32.0. Let's see. There we go. 32.0. So this is one way you can write some pseudocode based off the Smali code that you're reading. And you can figure out what's going on in the Smali code by writing this this Java code. It might help to have like a tablet or something to kind of write on instead of type it out, but whatever you prefer.